Welcome to part 20 of the Dargslan Linux series, the one where we finally tame the chaos of changing files. Git is a version control system, and once it clicks, it transforms how you work. Every edit becomes a saved snapshot, every old version stays recoverable, and every teammate can contribute without stepping on your toes. It's the kind of skill that compounds. Small effort now, massive payoff later. So let's start with that first command on screen, git init, and build from there. Here's the roadmap for the next few slides. We'll start with what Git actually is and why it beat out the competition, then break down the three areas where your files live as they move through Git. From there, we'll get hands-on with the daily trio, init, add, and commit, before branching out literally into parallel timelines and merging. We'll wrap with remotes, the collaboration layer that connects you to GitHub or GitLab, and gitignore, the unsung hero that keeps your repo tidy. So let's start with the what. Think of Git as a snapshot machine. Every time you commit, you're photographing your entire project, not just the lines that changed. Three things make this powerful. It's distributed, so every clone is a complete repo you can work with offline. It's snapshot-based, which makes recovery and branching lightning fast, and branches are basically free. Spin up 100, throw 99 away, Git won't blink. One quick clarification before we go further. Git is the tool. GitHub, GitLab, Bitbucket. Those are hosting services built around Git. Don't mix them up. Now, before you can commit anything, you need to understand where your files actually live in Git's mental model. There are three areas. The working directory is just your files on disk, what your editor sees. The staging area is a holding pen for changes you've marked as ready using git add. And the repository, that hidden.git folder, is where commits get permanently recorded with git commit. Files flow left to right, edit, stage, commit. Once you internalize this, the output of Git status stops being cryptic and starts telling you a story. So here's that flow in practice. You run git init once when starting a project. That creates the .git folder and turns a regular directory into a repository. From then on, your daily rhythm is a tight loop. Git status to see where things stand, git add to stage the files you actually want in this snapshot, and git commit with a meaningful message to lock it in. Sprinkle in git log, online whenever you want to see the timeline you've built. Master these 5, and honestly, you're productive already. Now, between commits, you'll spend most of your time inspecting what you've done and occasionally undoing it. Status and diff are your eyes. Status tells you which files moved. Diff shows the actual lines that changed. Log with. Own line gives you the timeline in compact form. And when something goes wrong, you've got 3 escape hatches. Restore throws away unstaged edits. Reset pulls a file back out of staging without touching its contents, and commit. Amend lets you patch up the last commit before you've shared it. Just remember that last one. Only before push. This is where Git really starts paying off. A branch is just a lightweight, movable pointer to a commit. Think of it as spinning up a parallel timeline where you can try a risky idea without ever touching main. The modern workflow is clean. Git switch -c to create and jump onto a new branch. Plain git switch to hop back, and git branch -d to clean up when you're done. If you've seen older tutorials using git checkout for all of this, that still works. But switch and restore are the clearer modern split. Once your feature branch is ready, merging brings that work home. The key thing to remember, merge always pulls changes into whatever branch you're currently on. So step 1 is switching to main. Then git merge feature login replays those commits and ties them together with a merge commit. If Git can't figure out how to combine 2 edits to the same line, it pauses and marks the conflict with those distinctive arrow brackets. You open the file, pick what you want, then add and commit to seal the deal. So far, everything we've done lives on your machine, but Git really shines once you share that history with others. A remote is just another copy of your repo somewhere else, usually on a service like GitHub. And by convention, we call the main one origin. You either clone an existing remote to start or attach one to a local repo with git remote add. From there, git push sends your commits up, and git pull brings down whatever your teammates have added, which, under the hood, is just a fetch followed by the same merge we covered a moment ago. With remotes in place, here's the rhythm you'll repeat every single day on every team you join. Start by pulling the latest so you're working on top of your teammates' commits. Then branch off main. Never work directly on main. One topic gets one branch. Make small, frequent commits with clear messages. Push your branch up with the U flag the first time to set the upstream. And finally, open a pull request in GitHub or GitLab for review. Merge, delete the branch, and tomorrow you do it all again. Now, before you start committing everything in sight, you need a .gitignore file, a simple list telling Git which patterns to pretend don't exist. 3 categories belong in there. Build artifacts like node modules or compiled .pyc files that get regenerated anyway. Secrets like .env or API keys that should never ever leave your machine, and OS junk like .dssuckstore that nobody else cares about. The pattern syntax is small but expressive. A trailing slash means a directory, double asterisk matches any depth, a leading slash anchors to the repo root, and a bang negates a rule when you need an exception. Now, mistakes happen, and Git gives you a different undo for each level of regret. If you've just edited a file and want to throw the changes away, Git restore brings it back to its last committed state. If you stage something by accident, Git restore staged unstages it without touching your edits. And if your last commit is wrong, missing a file, or with a typo in the message, Git commit amend rewrites it in place. One important caveat: only amend before you push. Rewriting shared history is a whole different headache. Speaking of headaches, here are 3 classic ones to sidestep. First, never commit secrets, passwords, API keys, .env files. Once they're in history, they're effectively public, so add those patterns to gitignore before your first commit and rotate anything that slips through. Second, don't force push to a shared branch. You'll erase your teammates' work. Keep force pushes to your own feature branches. And third, resist the temptation to dump everything into one giant end-of-day commit. Small, logical commits make your history reviewable, revertible, and far kinder to future you. With those pitfalls behind us, here's the short list of commands worth burning into muscle memory. Git status is your constant companion. Run it before and after almost everything. Git add and commit together capture a snapshot. Switch with -c spins up a new branch and jumps onto it in one move. Pull and push keep you in sync with the team. Log with online and graph gives you that picture of branching history. And restore is your quick undo for unstaged changes you regret. So let's pull it all together. Git is a snapshot machine. Every commit captures the whole tree, distributed across every clone, so history is essentially indestructible. Files flow from your working directory through staging into the repo, and once that mental model clicks, Git status finally makes sense. Init, add, and commit are your daily core. Branches are cheap, so use one per feature and keep main clean. And the rhythm to internalize. Pull, branch, commit, push, pull, request. That's how every team on Earth ships code with Git. And that wraps up Git. Next time, we shift gears into Part 21, Performance and Monitoring, where you'll meet the diagnostic toolkit production engineers actually reach for: IOStat, VMstat, SAR, and perf. When a server starts misbehaving at 3 in the morning, these are the commands that tell you whether it's the CPU, the disk, the memory, or something stranger. 20 down, 4 to go. See you in the next one.